Welcome to a new OpenStack online meetup. I'm very pleased to announce our two guests for this session. The first one is Director of Technology at SwiftStack and OpenStack Swift Project Technical Lead, John Dickinson. And the second one is Vin Provost, Product Manager of vStorage. And today we're going to discuss how these two projects work together. But first, you both attended the OpenStack conference in Paris, and what will you remember of the conference?
John, you go first.
Sure. Yeah, this Paris summit was great. I really like I've been around at OpenStack since the very beginning, and so every time we come to a new design summit and conference, it's really great to see kind of take stock of where we've been and where we're going, and really it's pretty incredible. I thought the amount of companies around the conference were really fantastic, and they were more broad and more diverse this time than I've ever seen before. Lots of new faces, which was fantastic. And then on the technical side, we had a great few days discussing some things in Swift and moving some things forward and being able to see each other in person. Overall, it was a great time, and of course it was in Paris, which I really enjoyed.
Okay, then I'll take over. Well, for us, we're from Europe. For us, Paris is only 3 hours driving, so that's not so special. But for us, what was really special about the OpenStack conference, and you have to know this was our first time as vStorage, as cloud founders. Well, we were a little bit amazed by the sheer size of the conference. We thought it would, or we think it was a small thing, but it was pretty impressive. For example, if you attend European conferences, you don't see many people from the US flying over. But with the OpenStack conference, what really struck me was that there were people flying from the US to Paris. There were people flying from all over the world, actually from Asia. A lot of people came from Asia, came to the conference, and that means that OpenStack is really business. That it's really booming. So that's really something that struck me, that I find important. And of course, yeah, you get to meet a lot of your customers, of people that are using the product, and that's also great because for us it's hard to go to the US and visit everybody. But with the OpenStack conference, everybody that's using us is coming there, and you have time to talk because it's 3 days, so you can spend some time and really discuss what their issues are and what they think of the product, and that's really great.
Guys, we want to talk today about how vStorage and Swift wire together. But before we do that, can both of you give a brief introduction into your projects? So let's maybe start with you, John, Swift and SwiftStack.
Sure. Yeah. Well, OpenStack Swift is the object storage implementation inside of OpenStack. It is one of the founding projects of OpenStack, and it's conceptually similar to Amazon S3. It is an eventually consistent storage system that can span global geographies and supports multiple storage policies, and it's built for scale. It's optimized for availability, durability, and massive concurrency across the entire data set. It's really great for unstructured data that can grow without bound, and it's really kind of interesting being here with Vim and seeing the vStorage stuff because it's adding new use cases to what we're doing. Now at SwiftStack, what we do is we deploy private cloud storage, which is based around OpenStack Swift, and we have our a management and monitoring controller that integrates that into a company's existing IT infrastructure, taking care of the monitoring, the management, the auth, utilization, and all those pieces. It's built around and uses 100% open source upstream OpenStack Swift, and then we also have a file system gateway so that legacy apps can talk to Swift without having to be rewritten to use the Swift API. So that's just a brief look at Swift and SwiftStack.
William, tell us please about vStorage. What is it all about, please?
Well, Open vStorage, it's an open source project, and we have here the vision at Cloud Founders, which is the sponsor of Open vStorage, that we want to build the fastest, the most awesome virtual machine storage for OpenStack, and we're doing this basically for a reason, because we actually need this inside our own data centers. We are building large private and public clouds, and we had really the desire to build something which was scalable, which was fast, and we quickly realized that the only way to do that was to use object storage as an underlying layer. But of course, object storage, you can't use that as a storage for virtual machines. You cannot run virtual machines directly, for example, on your object store. So what we had to do is we had to create technology, and that's what Open vStorage is really doing, that turns that object storage into block storage, which you can use as virtual machine storage. And of course, we need to make sure that it's fast enough. So what we did is we added flash or SSDs into the hosts, and that's our tier 1 storage. And then of course we use the object store as tier 2 storage. And that object storage, that can be, for example, a Swift or a Swift stack implementation. So we're quite flexible in that. And that means that you have the best of both worlds. You have really the speed of the block storage, like you would have with a traditional SAN or with an all-flash array, and you've got the scalability of the object storage.
That's great. Just a brief shout out to all those of you guys who are attending this session live. Feel free to ask questions while we're discussing, and use the chat window on the left-hand side of your ReadyTalk panel. Okay, John, do you think that using Swift as tier 2 storage for virtual machines, does that make sense?
Well, I think it depends on what you mean exactly by tier 2 storage. I think that Swift is fantastic for being used as well. One of the things, especially inside of the OpenStack world, that is generally a common first use case with Swift is backing up people's virtual machines and the sender volumes that they have and things like that. And that's certainly a good use case. But Swift was designed to really work alongside of the virtual machines, so that the applications running on top of the virtual machine can have access to a scalable pool of storage, that they don't have to worry with the nuts and bolts of the storage itself. They can simply treat it as utility and kind of offload some of those hard problems of storage to the storage engine. So that being said, I think that Swift works extraordinarily well alongside applications that are running in a virtualized compute layer. And the interesting thing to me with looking at stuff like Open vStorage is the fact that they kind of become a little more closely tied together. And while it's certainly not a use case I would have initially imagined for like Swift, it does sound quite intriguing, and it is something that is, I think, pretty interesting.
Mm-hmm. Now, I really want to add to John. John is absolutely right that applications should make use of Swift as an object storage, and that they should be rewritten to use that as a resting place for the data. But you have some issues there. And for example, if you're a bank and you've just spent 20 years optimizing your code and running it inside a server, you're not going to want to change that completely immediately. Maybe you want to do that over the long run, but you're not going to change that immediately to use object storage. And everybody is completely aware, and everybody knows that they need to move to object storage, except it's the pace that you move to, the pace at which you move to object storage. That's going to be a little bit hard for some companies. If you're a bank, it's going to be very slow. If you're an agile company or a new startup, it makes completely sense to use object storage, of course. But we try to make it easier for people who can not immediately go with object storage, of course.
Well, it sounds to me like some of what you're talking about, them, is that you've got a kind of an interesting bridge layer for a migration path for older applications, and I completely agree with you that that's there. But just in some of our conversations in the past, it does sound like there are some actually use cases that are thinking, hey, wait a minute, this is something that's it offers more than just a migration path. There's something a little new, as something that's a little more integrated and can be used as actually almost as like a tier one, just kind of, this is a first class citizen in your storage infrastructure.
Yeah, you're right. It's for some people it will be a migration path. For some people it will be the Holy Grail. I know that there's people on the chat that say that we're the Holy Grail because they really like Swift. They like the way how it works. You never have data loss. It's scalable, and they already have it in place. And now it's like the Holy Grail to run their virtual machines also on top of them. It's one platform that they need to maintain, and it just makes sense for them. So I think it's a good marriage.
Vim, you guys are positioning vStorage as the fastest block interface. Can you provide? Can you share any numbers here?
Yeah, of course. I think that was one of the questions that we had on our last chat. At the moment, we can do easily 15,000 to 20,000 IOPS with the current architecture. But of course, we're not sitting still, and we are trying to reach up to 50 to 70,000 IOPS per host, which means that if you just add more hosts, you can just grow your performance of your storage cluster very easily. And the way we're doing that is that we're adding some new designs. For example, we're completely redoing the architecture, the back side of our architecture. For example, we're implementing a dedupe shared cache across all the hosts, which means that we will really leverage the SSDs or PCI Flash which are in each host, and try to store as much of data in that cache as possible. So that's really something that we're trying to do. We're also doing some integration with QEMU. We're writing a library there so that we can directly talk there. And we are doing some optimizations with regards to shared metadata, so that you can do very quick recoveries, and that you could really run your volumes on any host. And we're expecting those new designs, those new architectures. So it's an vStorage 2.0 in the beginning of next year. So let's say the first weeks of January, we will do the first field tests with some customers, and then a bit later, then we will do a general GA of the vStorage, and it will be a supported version of vStorage. But it will really fly, and we really have the idea, or we really want it to be. We really wanted to reach that 50 to 70,000 IOPS per host, which means that it could easily compete with Nutanix or anything like.
Well, can I ask you just a couple of questions about that?
Yes.
One, I was just kind of curious. So the way it is set up is vStorage you've got a flash tier that you're using there to help accelerate a lot of storage there. So is the data then written to the flash tier and then asynchronously put to Swift and then kind of lazy loaded from Swift as it's demanded, or how does that work? Is it or is it just completely a pass-through thing that goes directly to Swift, and you're just chunking it up and taking advantage of concurrency?
No. What we're doing, we actually built a storage system which consists out of really two tiers. So the first tier is the cache tier, and there we have a location-based storage algorithm, which means that you can just do writes to the SSD, and everything just goes to the SSD inside the host. And we also keep a copy on a second host. Yeah, of course, in case the first host dies, you still have all the data left. And in that location, or in that storage system on the SSD, we have an always append methodology. So every write you do to the disk of a virtual machine gets appended to some kind of a log file. And once there are enough writes inside that log file, we close that file and we push it down to the object storage to Swift. Because it just makes more sense if you would do, for example, every 4K write, if you would convert that into an object onto Swift, it would just not be good enough. It would just, for example, exploit your metadata, because it just doesn't make sense to have every block written. It's not fast enough. So you need to have some kind of aggregation in the SSD layer, and then push it as really objects to the Swift interface, because there of course you can leverage the power of Swift. Does that answer your question, John?
Yeah, no, that does very well. Thank you. It looks like there was a question in the chat.
Yeah. You want to read this out to Wim?
Mm-hmm. Sure. Does vStorage integrated under the is it integrated under the hypervisor, or does it need a driver for each OS?
That kind of depends. OpenVStorage, if you have VMware, there you have a virtual storage appliance. So there is a virtual storage appliance. For KVM, it just runs bare metal on the hypervisor, and so it doesn't not need a driver for every operating system. It's not running inside the guest. It's running on the host itself. I hope that answers the question that was on the chat.
Yeah, you also have a Cinder driver, right?
Yeah, we also have a Cinder driver, of course. So if you have OpenStack, you can just use the Cinder driver. So if you create a snapshot, for example, in Cinder, or if you create a volume in Cinder, that gets converted into an API call on OpenVStorage, and of course we then execute that API call. For example, we take the snapshot, so it's really very nicely tied with OpenStack. So you see the snapshots that you take with OpenStack GUI. These end up as snapshots being taken by us, but you can also see them, of course, in the OpenStack GUI. So it's a complete integration there. But we have that Cinder plugin, and that means that you can really use every component of OpenStack. So you can use the Cinder functionality, and you can use the Swift functionality to run your virtual machines. You don't have to maintain, for example, an external SAN or something else to run the virtual machines. So it's really a nice. It's basically the missing piece that was missing in the OpenStack, the connection between Cinder and Swift. That's what we actually created.
Another question came just in. Since OpenVStorage only supports S3 today, will it add native Swift in version 2.0?
In version 2.0, we will not add native Swift. The reason for that is we have limited resources. We can't do everything at once. We're still an open source project. If you take S3, that's kind of the de facto standard if you want to support an object storage. So that's what we selected, but we are pretty sure that if we would go with a native Swift interface, that it probably would be faster, that it can even leverage more functionality of Swift. But at the moment we don't have that planned. It's just a matter of finding the resources and doing it.
John, the next question goes to you. Can storage policies be assigned to a container when using the S3 emulation in Swift?
So that's a great question. It would absolutely be possible, and I think the way that the integration would be built out is creating a storage policy in Swift for the OpenVStorage set of hardware. Now, the good thing is that while you should, if you can set arbitrary headers on with your S3 client, then yes, then that would be passed through, and on that container, or then the S3 parlance in the bucket create, you would assign it to the particular storage policy. But if you have the ability to use the Swift call to create the container, the storage policy is set on the container at the time of container creation. And after that, you can simply use that as anything else, and it's going to automatically put every object in there inside of that storage policy. So that does not seem to be a very high barrier.
You guys mentioned very briefly Project Cinder. And John, can you please tell us why doesn't Swift offer a block interface, and can you explain the role of Cinder in that context?
Sure. Well, the main reason that we don't support a block interface is not because we don't think it's a good thing to have, but because we don't want to try to be we don't want Swift to be the one storage system that does everything sort of thing. We want to stick to object storage and do that very, very well. Now, the interesting thing is that I think block storage and object storage are slightly orthogonal. You can find other open projects out there that provide block storage, but they're implemented as an object storage. The main difference that you're looking at is that is it something that's going to be good to use as volumes that provisions volumes for virtual machines or for compute instances, whether that's bare metal or virtualized or otherwise, or is it more kind of this pool of storage that you consume with an API? And we are sticking on Swift is sticking on to the pool of storage that's consumed with the API side of things, and that's the reason that we have Cinder inside of OpenStack itself. That provides the interface that you need, that when you're setting up your compute instance, it does allow you to attach and manage volumes implemented by whatever backend system you've provided that has integration with Cinder with that API. So they are for two very different use cases. And so Swift is sticking to the application storage side of things, and Cinder is managing persistent volume provisioning and management interaction with, very specifically, OpenStack Nova, the compute instance.
Two questions came in while you were speaking. The first one is, so the space in the SSD is spread across all VMs on the underlying host. How is that allocated between VMs? For example, loading multiple new VMs, freeing up SSD space from evacuated VMs?
Mm-hmm. I think this is for me. Well, first of all, we have two ways of using the tier 1 storage, so using the SSDs. We have a read cache and a write cache. And the read cache, that's deduplicated already, so that means that if you can share that between multiple virtual machines, which are using the same which are using the same pool. The thing is that of course it's a first in, first out. So if you're no, it's not really first in, first out. It's if you're not used very lately. So if your old data, you're not being referenced in the cache a lot, then we push it out. So then we make room for the new data, but we just share all the space across the SSD for every virtual machine. But it's really based on when the data was last accessed.
Another question. Okay, sorry. Go ahead, John. If you have anything to throw in.
No, I don't.
Oh, okay. So the next question then to you. vStorage creates a container for each vdisk, which is nice to prevent too many objects in a container. However, as John said, storage policies in Swift requires assignment of container creation. Will vStorage allow me to specify a default storage policy to use during vpool creation?
I would have to check with how it is set up right now. At the moment, we just create a bucket. It's just a bucket creation that we do. I don't know if you can specify a default policy with that. I think this is something that we need to check. I don't know, John, if you know if we just do through the S3 interface, if we do if we create a bucket, what kind of storage policy that will get, if we could do a default one or.
Well, if you don't send in for any container create inside of Swift, if you don't send a specific storage policy, it will use the cluster's default. But it's slightly different than saying that vStorage will use its own explicit one that's going to be used for every storage. It actually sounds like a pretty useful feature for having a multifunction cluster.
And why do you think it would be a useful feature?
Because that way I can have my vStorage always be putting into my my vStorage policy, which is configured as a separate set of hardware potentially as the rest of my cluster. It's still all managed the same as one big pool. But
Okay, so you would have like a storage
I've got
policy
other
for virtual
applications.
machines and sorry, go ahead.
Yeah, it will. I think you're getting right there. If you have your other applications that are doing that, say you have your backups that are put in 2 geographies and you want to set that policy there, or you just have a default triple replicated in your home office location, or your main office location. That means that more different applications are going to be consuming those and probably want to fall back to the Swift cluster default. And then you can have Open vStorage automatically set, hey, this is the storage policy we're going to pass along with every bucket create, and therefore it should. That's a one-time setting as opposed to lots of different applications needing to set their own explicitly.
Yeah, well, it makes sense. Probably we're not going to get it in there for version 2.1, but I'll definitely put it on the roadmap to keep it very close. Because the version 2.1, version 2.0, 2.0, that's planned for end of this to be feature complete end of the year. So we're kind of completely packed on that one. So it's going to be really hard to get that in there in the first version. So give us some time and we'll get it in there.
Fantastic.
All right. Let's talk about the pain points that people face with regards to storage in OpenStack. Ceph is largely being considered as the de facto standard for block and object storage. Ceph is obviously now part of Red Hat. Why should someone use Open vStorage in Swift instead of Ceph?
Mm-hmm. Well, I believe that OpenStack, well, we know the conference was great, so it's booming. But integrating storage is still a problem as how I see it. For example, you have the object storage platform, Swift, and you can use it to store images, to store backups. So you can have your applications, your new applications, put data into that Swift. But at the moment, nobody had the idea to actually also use it for the virtual machines. So you have that platform, which is great. But nobody's using it for virtual machines. So we said, okay, we need to do something else about that. And because now you need to maintain 2 separate storage platforms, one for block and one for object storage. And of course, you have Ceph there, and Ceph is good, but don't get me wrong. We support it as a backend, just as we support as Swift, but. It did the trick. It has that block interface, but it's not really. If you speak to people who are at the conference, it's not ideal for very large implementations. For example, it's got some flaws. Just to give you some examples, what we see is with Open vStorage we can get about 5 to 7 times the speed that we can get with Ceph, just because we are doing the caching completely different. For example, we use that tier 1 storage inside the host, and we do almost all the I/O on Flash. That's like. It's a little bit different compared to what Ceph is offering, and of course Ceph that's only going to work for KVM only. If you want to do multiple hypervisors, then you can't use it, and that's for example where we come in. I get really a lot of calls. From people using VMware and who want to use Ceph as an object storage, and that just doesn't work. And of course, the way how Ceph is using or offering block storage, it uses very small blocks. And remember, we said earlier that if you do small blocks, that's not going to work. Especially if you want to do erasure coding on those small blocks, that's not going to work, because if you have like 64 kilobyte blocks and you spread them up in even smaller chunks, your metadata of your object store will just explode, and it will not work. And maybe a last thing, of course, Ceph, that's now owned by Red Hat, and that, of course, I believe is a problem for people like Ubuntu, Mirantis, and HP, because it's selling something that they don't own. So it's good that there's an alternative, and which is of course much more mature than what Ceph is offering. And that's what that's Swift, of course, and it's open. It's not owned by a company, and I think that's a plus point for using Swift, for example.
Yeah, but I would say I have a slightly different take on that because I guess I'm obviously coming from a different perspective. I think it's fantastic to see all of these different options inside of the OpenStack community. I know that right now there are people who are actively working inside of the OpenStack ecosystem to make sure that Swift can talk with Ceph, and for that matter, there's people doing stuff with Daily, and there's people doing things with other storage implementations, like HP is doing their own thing. There's the stuff that works with Gluster. There's the stuff that works with looking at like the Seagate Kinetic drives, and just kind of a lot of different integration points that people have explored and worked with. And so in a lot of ways, I view Open vStorage as almost as an application that's running on top and just storing data in Swift. So I think it's fantastic to see the different people out there who are kind of building up different components of storage, and they're all, I think they're all kind of interesting in their own way. Some of them are better at what they do than others specific. They're good for one use case and not a different use case, and another one may be a slightly different way. So I think it's really kind of great if you can have something that is tying together like the Open vStorage on top of Swift, tying those together so that you have a sender interface on top of Swift blocks using Open vStorage. It's slightly different than the way that for example, Rafael, you mentioned Ceph specifically. It's slightly different than the way they're doing things, but it's depending on your use cases and what you're trying to build out. I think it's kind of great to see all of these things in the ecosystem.
Oh yeah, well, it's a great playground for everybody who's in open source. You can almost cherry pick your technology that you want. If you like something that Ceph has done with the interface, and you want to put Swift underneath, you can now do these kind of things, and that's of course great. That's the greatness of an open source ecosystem, of course. So I only see great things ahead, and the technology will only advance, because what you see is where you used to have that open source was following. You now see that open source is the leader of the pack, and that proprietary software is now following the open source components. And with these different open source projects, kind of, well, it's not really competing, but they're all doing storage, for example. They can only leverage each other and lead to better technology, of course, and that's what everybody wants.
Well, I think it's kind of funny because both of us are trying to be, or at least, just trying to say, oh, look, it's all really great because there's all these different options, and there's just all this kind of good stuff. But the reality is, at the end of the day, we have to have something that actually works, and it works well, and it works well for our use case. And so I'm not a big fan of going out there and saying that, well, you know what, this is going to be good for everything, and this is going to be your silver bullet to solve all your storage problems. I don't like systems that try to promote themselves as that. I also don't. I do think that, there has to be some choices made, and if you've got this kind of use case, you need to use this, and it's not, well, you've got 5 options you can choose from, and it means that every single person who has this particular problem has to go research 5 different things and build out their own clusters and spend months evaluating stuff. There's the big opportunities in the ecosystem and all of the things out there, I think, have some sort of a little bit of downside because you get this kind of paralysis of choice, and you're just like, there's too many things to choose. What do I do? Oh, let's just go with things I've been buying for the last 15 years. So, it's interesting.
That's a valid point, of course. You've got the choice, but on the other hand, that's where where companies like Cloud Founders and SwiftStack come in, and that's where they can give you a hand and help you make a decision and tell you, okay, this is a good use case and this is a bad use case. It's not because open source is the technology, the products around it, that's something completely different, of course.
Yeah,
and that's where really I see the value of companies like SwiftStack, for example.
Yeah, we've got people are interested in solutions, and products provide solutions, and it's not just some engine or cobbled together thing that can do that without generally a lot of work on your part to make it happen.
Mm-hmm. Yes. Yeah.
Guys, let's talk about use cases. Who do you see as a typical use case for the combination of both products, vStorage and Swift?
I think typical use cases are people who can or who implement, first of all, object storage, like a Swift stack. So I believe that's data centers, large corporations, universities, hosters, and who also run virtual machines. And typically that's all of these previous companies or use cases or users that I just named. That's data centers, large corporations, universities, hosters. That's the people that we with vStorage are targeting, and you see that it really provides them with some benefits. For example, if you see hosters, they are almost forced to offer an object store. Because everybody else is offering it. If you want to compete with the likes of Amazon, you need to have an object storage solution, and it needs to have an S3 interface. And if you want to go ahead, John.
I said or Swift.
Or Swift, yeah. Of course. And for a hoster, you need to implement that, let's say Swift, and then you've got it. So what else are you going to do with it? So if you already have that platform, why not use it for virtual machines and use OpenStack also for that, because it fits together. The other option is going with VMware, and then of course you know that you're going to spend a lot of money. There's an adagio which says if you got money you go with VMware, if you got time you go with OpenStack. Well, it's kind of true, but for hosters, well, the margin there is really small. Same as goes for universities. I know in Europe here the budgets are shrinking for universities, so they need to do more with less money. And then of course open source and this kind of projects where you can have like scalable storage and run your virtual machines on top of it, and in the meantime also offer an S3 interface or something like that, or an object store or an API to store objects. Then of course it makes sense, and this is really what you see. For example, in OpenStack, during the OpenStack conference, we had a lot of hosters and telcos at our booth, because they were interested about what we're doing and how we're using Swift, for example, or SwiftStack or any object store in that case. And they want to use it for, first of all, for greenfield deployments. If you're a telco and you don't have a cloud, it kind of makes sense to start using a scalable object store like Swift. And of course, if you already have a Swift, then it's like the right marriage, because you can use your object store that you already have and leverage it to do new stuff with it. And that's of course great. I don't know, John, if you see more use cases or different users?
No, I think your last point there is pretty interesting. If you look at people who are already using Swift, most people doing that are doing that at fairly substantial scale, and they're doing that in media storage, backups, document management, especially for those corporations that have to store things internally, like financial institutions, healthcare, insurance, things like that. And I think your last point is to say that, well, if you're looking at new use cases and new ways that you can consume this existing pool of storage, that actually becomes interesting. It's not a different way to do what you're already doing with your existing Swift clusters, but it's actually something new you can do with it. So if you can potentially solve new problems with your same existing Swift clusters. That's pretty interesting.
Mm-hmm. Yeah.
A question came just in from the audience. Both, since vStorage VM should not be replicated across regions, but instead backed up and replicated with VM application level software such as Veeam, Commvault, etc., does this make them a good candidate for erasure coding on an all SSD storage policy, or is this level of performance not needed?
Ooh, that's a very large question, Raphael. I'm trying to reread it now because we can see the questions coming in. Does this make them a good candidate for erasure coding on all SSD storage policy? I'm not quite sure on how to answer this one. I'm not really sure on how to answer this one. John, do you have an answer, or?
Well, I think maybe. It sounds like, so, let's see, I know who Doug is. Let's see, so since you don't want the vStorage block devices to be going across a region, that makes complete sense. Then let's see. I guess I'm not familiar with the backed up and replicated inside the VM application level software. Oh, okay. So the data on there. So you're going to use other software like Veeam or Commvault or other tools to back up the data that's on there.
Well, I think that there you have two options, or you could use, of course, the replication which is already in Swift. I would personally not do that because OpenVStorage is VM centric, so you would lose your VM centricness by doing the replication.
But that's not backup. It's just durability.
But backup that's going to be directly into Swift, so it's like a continuous backup. You have everything that has been written to that virtual machine is already in your object store.
Okay.
So there's no real need to do. Excuse me?
Even over time. So like
even over time.
If I have a 1 terabyte block and I mean a 1 terabyte volume, and I keep overriding the first 25% of it. Are all my historical rights stored inside of Swift by OpenVStorage? So they're addressable otherwise?
We store the complete. Let's say that if you do a write and you overwrite everything, we will store every write that you did in the past will be stored into Swift.
Okay.
Now, of course, this becomes a little bit crazy because after a while you want to throw a little bit away. Of course, for Swift it would be great because then it means that it gets larger and larger and larger. It's an option, of course. It's not. But what we have is a retention policies, which means that you can. Which could mean that you could set the retention policy that, so for example, everything which is past a certain point, it can be deleted. Or, for example, you only keep one monthly snapshot for 3 years, and then at the end of the month we keep the monthly snapshot, and then it's like with a backup solution, but it's already implemented, and we clean up the things that are in Swift but are no longer needed in Swift because it falls outside the retention period. Does that make sense?
I think so, and you also support the sender functionality to do the snapshots and backups to Swift as well.
Of
right?
course you can Of course you can do backups to Swift.
That's the OpenStack.
Yeah.
So I think in answer to the question, it sounds like that it would be. I think the erasure coding work that we're doing inside of Swift actually becomes quite attractive for the storage policy that you're using for OpenVStorage, because erasure coding doesn't really work across regions very well. It's fraught with peril. The same thing with OpenVStorage. You don't want to have that replicated across regions. So basically, you've got this set of storage that is managed essentially by OpenVStorage, at least it's read and written to by OpenVStorage, So doing erasure code there, while might be an interesting way to be a little bit more efficient with the storage, and it sounds like it is a great way for the two to work together, assuming you have the CPU needed to do that. Because vStorage is not doing these tiny little blocks, but is building them up into larger objects inside of Swift, which are more conducive to erasure code. It's also going to stay in the same region, which again is more conducive to erasure code. So that kind of makes sense to me.
You're absolutely right, John. I know you guys are working very hard on the erasure coding. As soon as it's out, it's really a good thing to use erasure coding together with OpenVStorage. We've done the calculations ourselves, and it would save around half of the hardware. So if you now have 2 boxes, you could go down to 1 box. Because typically if you see the overhead of replication, if you go with 3-way replication, that's 3. If you go with erasure coding, it's around 1.7 depending on how many disks you can lose. So you save around half of the hardware. So it completely makes sense to use erasure coding, and because we are constructing these we're constructing these larger objects, so we combine multiple writes into one big object. It's much bigger than, for example, a 4K write, and it's for example 4 megabyte or 16 megabyte, and that's really a sweet spot where you can do where you can start doing erasure coding. So it really makes sense to do erasure coding. I would do erasure coding instead of 3-way replication. And it's even a better way for the availability. With 3-way replication, if you're really unlucky and those 3 disks where those 3 items are, or those 3 objects are, crash, you lose it. The chances are, of course, slim, none. It's almost impossible. But with erasure coding, you could just lose X amount of disks, and it's just cheaper. It's really a good way to do it.
Yeah, because you're bundling them up into larger objects, and because those are not as active as potentially an individual block would be. That's to me why I think that erasure coding makes sense with OpenVStorage. Because otherwise it's just really expensive, CPU network-wise.
Yeah, you're absolutely right, John.
Yeah, guys, time is running. We only have 13 minutes left, and a couple more questions regarding, first of all, what are the pitfalls users should avoid when setting up an OpenVStorage and Swift implementation?
Well, let me start with one basic one. First of all, you should use SSDs for OpenVStorage just to get the performance right, just to make sure that you get the performance right. So these SSDs inside the hosts need to be enterprise SSDs. Especially if you, with our latest release, you can spread out the read cache and the write cache. The write cache needs to be on enterprise SSDs. If you use cheap SSDs, if you use like the consumer or the desktop SSDs, you will have a lot of problem because these we are very intense using these SSDs, and they will burn out very quickly. So my advice is really use enterprise SSDs. Now this is of course for every solution out there which is using SSDs. Always use enterprise SSDs for writes. Now for the reads you can use low cost SSDs because there we have the deduplication and it's only for read, so we are not doing many writes. It's not that you're going to overwrite the whole SSD every day, so you can get away with a lower quality of SSD, but for the writes always use a decent SSD. For networking, I think 10 gigs is almost a minimal, but I don't think that anybody else or that you want anything else there. I know that I don't know does Swift support just gigabit Ethernet, or are you requiring also 10 gigs?
What
John?
Swift requiring gigs? It's oftentimes used. It's not strictly required, but almost every deployment I see these days is using 10 gig networking.
Okay. Let me see if I can think of anything else. I think that's the major pitfalls from our side. I don't know if you have more pitfalls when you want to set up a combination of Open vStorage or SwiftStack, or things that you should look at, John?
Well, I would say that probably the networking, the reality is that as all of these storage systems get bigger and as we're storing more and more data, networking becomes a very hard problem. And that's where I would suspect that's where most of the pitfalls are. It's easy to say, yeah, I just got to use flash storage, but still got to move that around within the cluster and get it through those devices. So while a solution may be specific to a particular use case or a particular deployer, I suspect that networking becomes tricky.
Mm-hmm. Yeah, but I guess that's why you have companies like SwiftStack and Cloud Founders who can help you with setting that up and making the right decisions, right?
Yeah.
Okay. Maybe one more thing where I could give you some advice if you're setting it up, Open vStorage, with a Swift implementation. Use small disks. Small disks, yeah.
Okay.
What you see is if you're using like the big 8 terabyte disks inside Swift, or as the final resting place, as really where you put the data, it's better to have 4 2 terabyte disks than 1 8 terabyte disks. And the reason for that is you've got more spindles, and if data is no longer required in the cache, we push it down to the storage backend. And of course, you don't want that your storage backend becomes the bottleneck for your front end, because we have seen this already in our own clusters. We do a lot of writes, and if you underdimension the backend, you just can't get enough spindles out of the backend anymore if you have a cache miss, and especially if you have.
So you're looking at the aggregate throughput there.
Yeah. And that's why we say, okay, for example, if you have one disk of 8 terabyte, that gives you 75 IOPS, while if you have 4 2 terabyte disks, that gives you 4 times 75 IOPS, and you just can get a better performance out of that. It's the same amount of data that you can store, but you get more spindles there, and spindles are really key when you're doing storage. So that's a small tip that we're using here inside our own office to make sure that we can speed up things. It will work with 8 terabytes. You just get better performance if you have smaller disks.
Yeah, and to echo what Doug just said in the chat, this is why we want a storage policy for the Open vStorage specifically, because you're going to want to have different hardware used.
Yes. I understand. I understand that Douglas is really a fan of having those storage policies in there as soon as possible. But I'll definitely put it on the roadmap for a quick take up. So.
Okay, thank you, Douglas. Okay, guys. What is the potential? What do you see? What is the potential for the combination of both solutions? And then who should be afraid?
Well, if we see what the potential is, I think the total virtual machine storage market, or the storage market for virtual machines and servers, is what we are after, or that's a potential, and I think that's around 15 to 20 billion. So it's a big pie to share, and that pie should be shared across traditional sans NAS or flash arrays or hyper-converged solutions and software storage defined solutions. But it's a big market, and I really think that traditional sans or NASes, that's already part of history. All flash arrays, it's going to be hard for them also, so you need to go with a hybrid solution where you have some storage, or where you have SSD storage as a tier 1, and then something as a tier 2 storage to have a final resting place for your data. So I think that's the persons the companies that really should be afraid. I don't know, John, if you have more to add, or
Yeah, I do. I think what's really interesting is that we can already show, and I know that at SwiftStack the things that we see every week is people choosing Swift and SwiftStack specifically over more traditional storage systems, moving off of more expensive public clouds, and so essentially disrupting the existing market, so that you don't have to go buy these large SANs. You don't have to go buy to store your documents and your backups. You don't have to go buy these more traditional and very expensive pieces of hardware that have hardware lock-in and all this kind of stuff. So we already know that just Swift by itself is challenging the existing storage market, which is huge. And being able to, I think, back to the earlier point as far as the use cases, when you look at the possibility of open storage being able to add on functionality to existing Swift clusters so that it works better in certain compute instances as well, well, then you've basically just expanded the pie of possibility, and that's exciting.
Mm-hmm. Yeah, I think you can. I think we can just safely say that it's a big pie that we can eat, and there's a lot of opportunities there.
And everybody likes pie.
Yeah, that's right. That's right.
Guys, one
Okay.
final question. We talked very briefly about some features that might come up in version 2.0. How do you see the future of the future of both of your projects within OpenStack? Let's say beyond version 2.0.
Well, I think,
John?
I'll speak to Swift. Yeah, I'll speak to Swift first. The things that we've mentioned already, that we're actively working on supporting erasure codes as a storage policy alongside of replicated storage policies. That's huge for Swift. And there's lots of other conversations that we've got ongoing as well. Some interesting things we discussed in Paris just a few weeks ago at the summit have to do with things along the lines of searching and indexing and encryption and things along the lines of just making sure that performance is really good. So those are all really great things there. But the common theme in a lot of those kind of things that are being discussed in the ecosystem, where I see people coming around OpenStack and Swift specifically and looking for opportunities, is very similar to exactly what Cloud Founders is doing here with vStorage. It's built around the key concept that we have in Swift now of storage policy. And so that you can actually say, this is a piece of my hardware, and I can configure the entire pool of hardware to exactly match my use case. So I've seen that, like we've been talking for the past hour, on with vStorage, and I've also seen that with companies like I mentioned earlier, with other software storage engines, with other pieces of hardware, whether that's new cutting edge stuff or more traditional things. That's where I see a lot of activity and excitement and enhancement and opportunity going forward, is being able to build on top of what we've got in Swift right now, the storage policies, to enable these new use cases. So for me, that's what I see going forward with the future with OpenStack Swift.
What I see as the future for vStorage, well, first of all, I don't think I can dodge the ball where we are not implementing the storage policies anymore. There's too much demand for that, and I want to see a more tighter integration from vStorage within the OpenStack community, because we really are almost 100% sure, or no, we're 100% sure that OpenStack is the way forward. We went to Paris, and it really opened our eyes. It is a great community and we really want to be make a better part of it, or want to be a bigger part of that. And I think that our future will be a success if we can be the de facto standard, or the de facto standard storage solution for OpenStack virtual machines. And I think we can achieve that. And I really hope that we can leverage Swift together with us, so that